Welcome to lesson 48. We're in 48A, the first part, powers of trigonometric functions. So let's look at these three opportunities to write a power of a trigonometric function. The first one has the power on the degree of measure. We almost never use this because there's really never the opportunity for us to have the power of the degree of measure. So you can do it. You can do that power. You can say 30 times 30, which would give you 900 degrees. That's how you would solve that. But we almost never use that. So it's just worth mentioning how to solve it in the off chance that it might come up one day. In this event, you just use the exponent on the degree of measure if it's written like this. This is the way you're going to more commonly see it written when you want to take the power of a trigonometric function. And both of these mean exactly the same thing. This one puts everything in parentheses and has the power applied to after you find the sign of the degree of measure. This means the same thing. This is the one that we're going to use the most. This is the one you're going to see the most because it's the faster and the easier of the two to write, which we know, which is what mathematicians prefer. They prefer the least amount of effort, right, to get the same result. They don't want you to go through a million steps or a million symbols to get to the least or the most succinct method, or to get the same thing. So this is the one that we're going to see the most in our problems. But both mean exactly the same thing. And what they mean is to take the power after you find the sine, or after you find the cosine, or the tangent, or the cosecant, or whatever it is. So this will be an illustration here. This is the second one, the sine squared of 30 degrees. So you would find the sine of 30 degrees, which is 1/2, and then you would square that, which would equal 1/4. This first one that's written, the sine of theta, or 30 degrees in this case, squared, the whole thing squared, it's the same thing. You find the sine of 30 degrees and then you square it, and that would still be 1/4. So that is how you would take a power of a trigonometric function. It does depend on how it's written, but you really only have two things you have to worry about. Are you taking the power of the whole thing after you find whatever it is, the sine or the cosine or whatever, or are you using the power on the degree of measure? And like I said, we'll almost never use power on the degree of measure. It's typically going to be right here next to your trigonometric function, and it will be applied after you find whatever that is. All right, so let's do some practice problems. So we're going to find, this is 48.1, and you have an A and a B. A wants you to find the cubed sine of negative 60 degrees. And then B wants us to find the cotangent squared of 330 degrees. All right, so because of our unit circle chart that we have, we don't even have to really do the math anymore, do we? Let me go, I've got it up in Canva right now, and this is the actual chart, or the actual form. I created the PDF form for us in Canva, but we're looking for the, what was it? The sine of negative 60 degrees. So the negative 60 would be the same as 300. And the sine of that is going to be negative square root of 3 over 2. See how handy that was? Negative square root of 3 over 2. And then that is what would be cubed. Okay, so negative cubed is going to be a negative. And then we have this cubed is going to be 3 times the square root of 3. And this cubed is going to be 8. That's your answer. Aren't those easy? Especially now that we have our unit circle chart, so we don't have to deal with all of that. And so our cotangent of 330, let's look at that. So here's our 330, and our tangent is going to be -1 over the square root of 3, right? So the cotangent is -1 over, that is our tangent. So our cotangent would be flipped. So that would be square root of 3 over 1, and this is negative, so that would be a negative square root of 3. Because we flip it. This is the tangent, this is the cotangent. So it's a negative square root of 3, but we're squaring it. So a negative times a negative is a positive, and square root of 3 times square root of 3 is going to be 3. So our answer is 3. That's our answer. Right? So it's with the chart, it makes it super easy. These are not complicated problems. They just look hard. Doesn't make you feel smart. You can look at that and go, I know how to solve that. I can do that. So use your chart. That's what it's for. Pull it up. Pull those reference things. Don't you wish you had that chart sooner? I kind of wish we had it sooner too, but this is what it introduced it in the book. And part of the reason for doing that is so that you understand what all that stuff means on the chart. Okay, so it does make it easier for you, but it's all about understanding it first. It's kind of like multiplication tables. You have to understand how it works first, and then they have you just memorize it. So that one was pretty easy and pretty straightforward. 48.1. Let's do 48.2. So 48.2, it says we want to evaluate the cosecant squared of -405 degrees minus the tan squared of 45 degrees. All right, so first we make our sketches, or we refer to our unit circle with the related angles, and we get all of our information, and we find that the cosecant of -405 is going to be a negative square root of 2 over 1, and that's squared, minus the tangent of 45 degrees is going to be 1 over 1, and then we square that. All right. So when we square this, we have, this is a negative square root of 2 over 1, so that's just a negative square root of 2. When we square that, we get a positive 2. And this is 1 over 1, and when we square that, we get -1. So our answer is 1. Easy peasy. We had to come all the way to Algebra 3 to get back to first grade math. Isn't that funny? Maybe it's funny to me, might not be funny to you, but that's all we have for 48A. So do the practice problems that follow, and then we'll do 48B.